Let me tell you about a production incident that looked like a data problem. Users complained saying, I'm seeing wrong information. This doesn't match what I just did. Why is the application lying to me? Nothing was slow, nothing was down, nothing was erroring. And yet, the system was returning the wrong truth. This is one of the most dangerous failures in production. Before we go further, if these incidents feels real to you, like this video and subscribe. I'm running a 30-day real DevOps incident challenge. Complete the challenge and I'll personally send you a free DevOps simulation ebook. All right. Let's go deeper. What this episode is really about. This is not about Redis. This is not about Memcache. This is not about any tools. Specifically, what happens when your system returns confidently wrong data. Slow system annoys users. Broken systems frustrate users. Wrong systems destroy trust. Imagine a normal production setup. Requests hit API. Cache sits in front to make things fast. Data comes from a database. Everything works fine. Latency is great. Costs are low. Dashboards are green. Until one day, users start reporting, saying, I see someone else's data. My update didn't apply. This value is old. Refreshing doesn't help. This is where real panic begins. Just like day 5 and 6, something changed but not obvious. For example, a new cache key, a TTL adjustment, a serialization change, a background refresh job, a partial rollout, a feature flag interaction. Everything still works. Cache still hits. Database load is low. Database load is low. Latency is perfect. And yet, wrong data is spreading fast. Here's what most engineers miss. Caches don't store data, they amplify mistakes. One wrong response gets cached, gets reused, gets trusted, gets trusted, gets served thousands of times. The cache isn't slow. The cache isn't broken. The cache is efficiently wrong. And that's terrifying. Why this is hard to debug? Because logs look fine, errors are zero, latency is excellent, DB data is correct, but user sees something else. You now have two truths, two realities, two versions of the system, and nobody knows which one to trust. This is where teams argue. This is where incidents get political. This is where confidence collapses. Now, the real damage starts. Users make decisions on wrong data. Orders are placed incorrectly. Payments are retried unnecessarily. Support tickets explode. Trust erodes silently. Money doesn't just leak, reputation leaks. And reputation is harder to fix than most outages. Why flushing cache is not a solution here? Someone says in our team, let's just flush the cache. That feels right. Okay? Sometimes it definitely helps. Sometimes it makes it worse. Because cold caches overload databases. Wrong logic repopulates cache. The poison returns. This is not a cache problem. This is a system contract problem. How engineers think here? Very few engineers don't ask, is cache up? They ask, what is cached? Who owns the cache key? What assumptions does this key encode? When should this data change? Who invalidates it and when? They think about data lifecycle, not performance. This is day 7 of the challenge. You are on call. System is fast. No errors. Users see wrong data. What is the first thing you would investigate here? Not the fix, not the command, not the tool. You're thinking. There is no single correct answer here. This incident separates engineers who trust caches blindly versus engineers who understand data contracts. Comment your thought process that keeps your day 7 streak alive. Caching makes systems fast. But when it goes wrong, it spreads lies at scale. Day 7 teaches one brutal lesson. Fast and wrong is worse than slow and correct. Tomorrow is even more subtle.